till the additional extension of the short break. Thank you very much for the fruitful discussion that has been conducted from the trial session. Continuing the next session, we are now approaching the second keynote speak session. Dr. Andrea Grech La Rosa from the University College of London will resume the academic discourse on SRCM from the first keynote speak session with more intriguing points of discussion in many aspects. To lead the presentation and discussion in this current session, we would like to invite Professor I Ketut Arya Priya Utama to moderate the second session of the keynote speech. So, without further ado, Professor I Ketut Arya Priya Utama, the time for moderation is yours.
Okay, thank you very much, Stefan Nugroho, for letting me being the moderator for the last session. Ladies and gentlemen, all of the audience, thank you very much for your patience for the last session. In this case, Andrea Grech La Rosa from University of College London will present the work on development of application of stability checking on a fishing vessel. Dr. Andrea sent his video already, will be soon. He sent apology because he cannot attend directly because at the same time he has another important appointment. For your consideration that the presentation is part of the work of Newton Fund between University of College London, ITS, University of Patimura, and PT Aurelia Shipyard. So before I let the committee to present the video, I would like to introduce the member of the team. Okay, one is of course Dr. Andrea, Professor Giles Thomas, myself, Pak Doni Setiawan. Could you show up, Pak Doni?
Hello, yes, Prof.
Okay, Pak Doni Setiawan is a senior lecturer at Naval Architecture Department ITS. Pak Sugeng Riyadi, my PhD student and one of the director at PT Aurelia Shipyard. Hello, Pak Sugeng. Pak Sugeng. Okay, he is coming later, I think. And last but not least, Dr. Walter Hetaria from Patimura University.
Hello, everyone. Good afternoon. Nice to meet you.
Okay, thank you, Pak Walter. And now let us see the presentation of Dr. Andrea Grech La Rosa. If you have any questions later, the team member of the research will try to answer your questions. Okay, thank you. Let us see.
Good afternoon, and welcome from very, very rainy London. Thanks for giving me the opportunity to present at this conference. I'm unfortunately not able to be here and in live, I suppose, but I'll be more than happy to take questions via email when after today. So today I'll be giving you a presentation based on a project that I've been working on for the last couple of months. It's relating to the design of a mobile application to be able to assess the stability of small fishing boats. So I don't need to, explain to all of you how important fishing is to Indonesia. It's the livelihood for many people who live around the Indonesian coast. It's a decent portion of the Indonesian economy, and I mean there are various types of fishing and types of skill that are involved to catch these respective fish. Thing is that although fishing is in principle a very dangerous way of earning a living, it turns out that in Indonesia, things are a little bit more dangerous than we would like. Unfortunately, there have been numerous cases of fishers going missing, boats capsizing, and unfortunately, in many cases, lots of casualties and people perishing at sea. And this has been recognized by various researchers, Indonesian and otherwise. But a particular report that published by the Lloyd's Register Foundation really goes into detail and identifies these respective points as being some of the most valid for the cause of these casualties. And here we have an article, just one simple newspaper article showing the reality of the situation. There's a poor safety culture on board these boats, using the idea of I've been fishing on this, I've been doing it the way I do it for so many years and nothing's ever happened. And unfortunately, nothing ever happens until something happens. So there are still more cases. Until recently, I saw another article with the similar sort of fate. So my point is, this is not something of the past. This is very much a real and live issue that ideally needs to be addressed as quickly as possible. So I suppose from my perspective is, what can we do to address this? Is there a solution, or is it something which is just so impossible to deal with that it's just not possible? A bit interesting side note is that we were first trying to see what resources were available to Indonesian fishers to begin with, and because as much as possible we didn't want them to have to buy something new. And one thing we found out very quickly is that a large proportion of these people have access to mobile phones, and even more specifically access to smart mobile phones. And this is not because of any particular safety aspect, it's just simply because it seems that statistically they're known to earn a little bit more money by having a mobile phone, because they can call the market beforehand and at least know roughly where to go to be able to sell their catch. And hence this has been one of the reasons why they associate phones in a positive way, because it almost always means that they're more likely to have a higher income. So we now know that they have these mobile phones available to them. Now, the thing about smart mobile phones is that they're also equipped with various sensors, including accelerometers, gyroscopes, GPS, and many others. So, and this again is not for any specific reason other than there are so many applications. There are so many applications that make use of mobile phones, and therefore need to have these sensors to be able to work, especially in sort of like games and getting directions to go to places, that these sensors are inherently embedded in it. Another very important point is that these phones in principle are only becoming more and more powerful and complex, and that can also be applied to the second-hand market and the lower entry phones. I think you'll all agree with me in saying that a phone that was, top of the range a handful of years ago is now an entry-level phone now, and it doesn't seem as if things are going to be changing anytime soon. So in a nutshell, what we're thinking about is whether we can use a mobile phone as a data acquisition system and also some form of data processing to be able to help us. So the overall goal for this work was to improve the safety on board Indonesian fishing vessels with the help of smart mobile phones. And we brainstormed and thought about various ways in which we could use this powerful resource that is, within their pockets to a certain extent, and concluded that we could potentially come up with some stability application that would, one way or another, determine whether their boat is stable or not, and at the very least alert them if it's not. And we've obviously needed to have some requirements. Excuse me. And we obviously need to have some requirements. The most the most important of which was that it required absolute minimum effort, i.e. we do not expect these people to say going through a whole, to really go out of their way to do some analysis. It needs to be quick and it needs to be simple to do. It also needs to deliver a clear and simple message, so no technical stuff. So it needs to be something easy to understand and appreciate. And we also wanted to give some form of guidance if the vessel is identified to be unstable. Being told you're unstable and not saying how to try and solve the problem is not particularly helpful to them. As I've said before, we also wanted to have no additional hardware required. Excuse me. No additional hardware required, because we do not imagine them wanting to spend any, money on stuff or on additional things. Another important point is that because the mobile signal out at sea varies so much, we wanted this application to work without a SIM card and without internet connection, i.e. all you need is a smart mobile phone. So the idea behind this app is that we will be measuring the roll motion of the vessel, and we'll be conducting some form of analysis to determine the boat's health, and we'll be using some form of visual and audio guidance to be able to tell whether, to be able to inform the fisher whether they are stable or not. The application will have two main functions. There'll be a test that can be conducted beforehand and another test after, whilst they are underway, whilst they're moving. You do not necessarily need to do one before the other, but it would be strongly recommended. So the idea is that in the pre-departure test, once they've loaded their vessel with everything that they need to take with them, they do a test to be able to determine, whilst they're still close to shore, whether certain changes need to be made, certain weights need to be taken off or moved down, and then hopefully once they get rendered their vessel stable, they're able to then monitor how stable they remain as they are fishing and passing through waves and all of that, because the loading condition of the boat does change in time. Now for the pre-departure test, I found actually quite an old video that shows what this involves. So the idea is that you would add some form of excitation force to the vessel to make it roll. Over here we're seeing these men pulling on the mast to get it to move from port to starboard. And what would then happen is when you let go, you just see how long it takes to decay. Depending on that outcome and how and basically the roll period from one oscillation to the other, you're able to predict or get an estimate at the very least of what's known as the metacentric height. The metacentric height is one of those key variables that can help identify whether a vessel is stable or not. So in terms of the user process, what we're expecting here is them to load the vessel, to put the phone on board the boat. It needs to be, the center line of the mobile needs to be parallel to the center line of the vessel. It doesn't have to be on the center line, but it needs to be parallel to it. Then the user would need to input the beam. The beam is how wide the vessel is. They would start the test, incline, as I've showed you in the previous video, and then stop the test. The phone will then conduct the analysis, and depending on the readings that would have recorded, it would give an output of what the result is. And here is an example of what that looks like in real life. So, this was a rough test, as in this is not on a real boat. This was just a mock-up. But again, it gives you an idea of what we're working with. So we're doing stability at rest, which is the pre-departure test. We get this oscillation of the vessel, and by doing the analysis, we can estimate what the GM is, and we eventually, when this is given, at the moment we're still in the test phase, so when this is eventually given to the fishes, there wouldn't be all those characteristics written down. It would just say good, average, or bad. And if it's bad, they will, or average actually, we will give guidance on what they can do to try and make it better. The second function is that of the continuous monitoring. So over here, in a very similar way, you would load the vessel, dock the phone, i.e. again, put the mobile phone parallel to the center line of the vessel, input the beam. So if you've already done before, you wouldn't need to do this, and you would just need to literally press start analysis. And so long as the mobile phone remains in the same position, i.e. on some deck or surface parallel to the center line of the vessel, the roll angle of the vessel will be continuously recorded, and the analysis will just be happening every couple of seconds and refreshing. And this will give the user an indication of whether they are still stable or not, or potentially whether they are doing something particularly dangerous while they are out at sea, to hopefully make them, if possible, at least stop doing that before an accident happens. And this is again a screenshot showing what that would look like. So it would effectively be a graph, and it would be giving out, it would be changing color depending, using the traffic light system, depending on whether it's stable or not. So red in this case means not stable, green is stable, and orange would be, borderline stable. At the end of the day, this will always be an approximation. We are at the moment in the process of working out how to make it as accurate as possible, so that we don't give fishers a false sense of security when they go out to sea. Over here I have a live screen video of the app in action, which I thought I'd share with you. So I've gone into the function saying stability at rest, and I've started the test. And over here I am moving the mobile phone in this motion, and as we can see, we are recording the angle, or what would be the roll angle, as time goes on. We then press stop, and we can see what the overall result is. Like I said, this is still in the development phase, so the numbers don't actually make any sense. But again, the idea is that we would get an indication of whether it is stable or not. Because we are in the test phase, we can also save the data, so we can process it later on. In the continuous monitoring test, we're doing something very similar, as in we're just on the vessel and we're rolling from one side to the other. And again, this is in my hands, this is not really on a boat, we're not really going at 80 degrees roll angle. But again, the idea is that we're moving from left to right, we're seeing what the roll period is as time goes by, and then we're correlating that roll period to the metacentric height, and then using the metacentric height as our conditional number to determine whether the vessel is stable or not. So far we've identified no specific issues with battery life and all that, but I suppose if you're going to be out at sea for multiple days, then maybe this would be an issue. We can also vary various settings. The most important one for fishers would be the beam. So if they go on their friend's boat, for argument's sake, they can use the same application without having to download something again. All they need to do is just measure the beam, or input the beam. I've had the fortune and absolute pleasure of going to Ambon and even Surabaya actually recently, where we did some tests. This is with collaborating with the University of Patimura as well. Over here we did the two types of tests. We did the roll decay tests with the help of some very enthusiastic students, which was lovely. And we also did some continuous monitoring tests with the pulsane vessel when we went out to fish between something like 1 and 7 in the morning, or 1 and 8 in the morning. It was quite an experience, which I enjoyed very much on a professional level and also on on a personal level. Now, to try and understand the limitations of mobile phones, we had a setup which was, well, I suppose very basic. We were using the 4 mobile phones that you can see in the image, as well as an IMU. So basically, there's a sensor designed specifically to measure accelerations and angles, and that was there to validate. And we had a 5th mobile phone that was not using the app, it was using some third-party software to just record data. So the idea behind all of this is that we can see whether how accurate or not they are with each other, because they, at the end of the day, they are on the same boat, and to see whether there are any discrepancies, if any, and how big or small it is. How much, whether the battery life was an issue, for example, or whether there were whether there were other things that maybe we didn't necessarily factor in. And again, here we can see a live feed of how it was on board the vessel. They look different because we've noticed that depending on the phone that you're using, the scale changes. But in principle, now in post-processing, which is what I'm currently working on, I can comfortably say that the discrepancy between the mobile phone data is minimal, or at least certainly for what we're trying to achieve, minimal. We've in the past asked these questions, which I thought I'd ask you as well, just in case you'd be happy to pass on your feedback. But we're very much interested in understanding what we can do to encourage these fishers to use the app. I mean, we've created it. It's going to be free to use. They'll be able to download it so long as they have an Android phone. But that won't necessarily encourage them to use it. So we'd like to ask you what you think we can do to try and encourage them to use the app. Like I said, so far this application focuses on boat stability, but we'd also like to ask what you think maybe we could add to the application to make the app more useful for them. Because at the end of the day, we generally want to try and help. And maybe if there's some additional feature which you think would be useful, it would be great to know. And finally, just in general, I suppose, whether you are aware of any safety or operational issues that are important for Indonesian fishers to take note of. Naturally, you don't have to do this, but if you are happy to provide us with some feedback, that would be great. So, like I said, I'm not in a position to answer questions live now, but I'm more than happy to take questions via email at a later date. So here you can find my email address, and it's again, I wish I was able to be there in person, but I'm sure you'll have a great time listening to the other presentations. Thank you very much, and I look forward to hopefully meeting with you sometime in the future. Bye-bye.
Okay, thank you very much, audience, for your attention. Okay, following and listening the description from Dr. Andrea La Rosa. He is actually a new doctor from University of College London, supervised by Professor Giles Thomas. So for your attention, the work actually funded through Newton Fund scheme between UCL, ITS, and other partners in Indonesia. The work is not finished yet, will be continued, and we are seeking extension funding from Lloyd Register Foundation. Okay, sorry, something just happened. Yeah, let me continue. So the work is being continued, and we are seeking further funding from Lloyd Register Foundation in the UK, and then we can improve the application to be used by Indonesian fishermen. One good point, actually, as Dr. Andrea mentioned, that this application will be provided for free, will not be patented as all usually people do. So people can use the application on their mobile phone. They don't need SIM card, internet access, just copy the apps or the program on their mobile phones, and they can use as Dr. Andrea mentioned. Everybody can ask through email. I will be provided soon. However, if you have any direct questions, my colleague, Mr. Sugeng Riyadi, who is directly on the boat when the test was carried out, will be happily to answer the questions. Okay, please, if you have any questions, you can say directly, or you can put on chat, and I can read it for you. Okay, thank you. Bu Warma, please, if you have any questions. Pak Sugeng, are you ready there? Pak
Yes,
Sugeng, hello.
yes. Okay, yes, Prof.
Yeah, I believe you better answer because you are directly following the test. Yeah.
Yes, okay.
Please, Bu Warma.
Yeah, Professor Ikap and also Pak Sugeng and the colleagues, because this is like a consortium research. I would like to asking, because as I know, the type of the fishing vessel in Indonesia, they have a different type, as I know, because in some area like in Banyuwangi, in Ambon, or in several area in Indonesia, the type of the small boat for fishing vessel actually is different, right? Because they have a different different wave, different condition in each of area. This application is, my question is, this application can be used with a different type of the small traditional vessel that we have in Indonesia, or they need some adjustment for the model, especially for the application, especially because this is very important for our fishermen in several areas in Indonesia. This is my question. Thank you.
Prof. Ikap, I can answer the question of Ms. Warma.
Yes, please.
Okay.
You should answer, Pak Sugeng.
Okay, thank you very much. Thanks for your question about the application here. Actually, when we're talking about the stability, the procedure to know about the vessel is stable or not, I think very complicated. I think we must be use the standard of the calculation like inclining test. I think with inclining test, we have known about the line span shape of the boat. Yeah. And then after that, we calculation, we arrange how much the can make some rolling, and then we calculate with standard of the naval architect standard to know about the stability. But for this case, our team make this application to find out the small fishing vessel less than 15 meter. Jadi 1.5 meter. I think the shape of the boat, I think we can know not use directly with the shape of the lens plan, but we can know about the decay test. I think decay test as soon like the Dr. Andrea shown in the presentation, the fishing vessel we make some maximum decay, and then they after that they just only keep ongoing until the vessel is steady. Yeah. After that, the apps will be calculated. So when you ask about the different of the shape, different of the it means the length and everything put in width of the vessel. I think we can know about the variation about different type with the decay rolling of that vessel. So with this application, we can know about the initial of the stability, even the different of type of shape. As you mentioned, maybe in Banyuwangi is different, in Patiran, maybe in Ambon. With this app, we can know about the initial stability. And then the continue for the continuous monitoring, there is app can put in the vessel is going on, and then they have some recognition before, or we can directly put in the vessel. They can know about the stability. He is a safe or not. So I think this is a good idea for our team, Dr. Andrea, to make some application to know the stability without know about the shape of the vessel. So finally, I think as your question, I think this vessel still ongoing. But we last time we just testing in the one of the vessel in Ambon. So we try to looking the funding again to make some experiment to other vessel. But as I know, I think it's not so much different we compare with the other shape vessel or boat or fishing vessel. But actually, we must be check again with the another experience to know what the difference if the another vessel come from another island. I think it's still going in research, Mr. Warma.
This is
Thank you, Pak Sugeng.
Yeah.
But can I asking only one question, a simple
Yes.
question. It can be used for the different type of material, because we know that the material from the ship is a lot. Sometimes in the fishing vessel, they are using sometimes composite, or sometimes they're using fiber, or sometimes they're using steel like wood. So it can be used for any material.
Can use for any material, because the characteristic of the ship, the vessel, I think the center of the gravity, I think center weight of the vessel and the position of the center gravity. I think there is same yeah. If we compare with this light or the heavy, I think its position rolling is more different. So we can capture about the different of the type of the material we can catch, and the transform to the stability is good or not. That's my answer.
Thank you, Pak Sugeng.
Okay, thank you very
Thank you.
much.
Okay, if the audiences have any other questions, please, or you can send email directed to Dr. Andrea. Yeah? The email address actually can be found in the chat room. a.grech.11@ucl.ac.uk. And for the attention, Bu Warma, the extension of the work involve Pak Putu Arta from PPNS.
Yes, Professor. Thank
Yes,
you.
this actually is part of the collaboration with other institutions in Indonesia. And the benefit will be delivered to fishing community for free. At least we can help the community to reduce accident of the fishing vessel. Okay, if there's no further questions, okay, I give back this session to the MC, to Mas Stefan Nugroho. Thank you.
Very well. Right. So thank you very much, Professor Arya Priya Utama, as the main moderator of this second keynote speech session, as well as another bonus moderator, as well as additional source of information, Mr. Sugeng Priyadi. And we would like to extend our gratitude for Dr. Andrea Grech-Larosa as the second keynote speaker, even though he is currently unable to attend the live session of the second keynote speech. So thus, we have reached the end of all of the sets of activities that has been set up for SRCM 2022. Before we would like to close our event, to sum up our experience and enlighten you on the next, please welcome Mr. Aji Pamungkas as the chairman of SRCM to present the closing remark. To Mr. Aji Pamungkas, the time is yours.
Yeah, thank you very much, Mas Stefan, in conveying the seminars. Yeah, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon, everyone. Yeah, I'm back to give you some highlights for our journey today. Dear speakers, presenters, and distinguished participants, I'm very, very happy to have been able to take this part in SRCM this year. And I'd like to thank you, every participant who have joined from start until the end of this joint conference. This conference wouldn't be as lively as it was without your presence in it. And the third SRCM joint international seminars have provided a place for academic and practitioners to discuss responsible and accessible coastal management. We can see that from Prof. Daniel's presentations, we understand about coastal management through sustainable mangrove conservations. And we also have an insight from Prof. Harry about the application of solar radiation management in Indonesia, trying to slow down the climate change phenomena. Both of them has enriched our horizons on climate change and coastal management. I think there are nearly 100 or maybe more than 140 participants have actively participated in the Zoom, maybe some of them through the YouTubes, yeah, and enjoying the discussion in QA session in its peak time. And the midday sessions, we have 52 presenters in 6 breakout rooms, giving their insight in each of their research. From room 1, we can see there are discussions on sustainable constructions, where virtual of ICT supported has reached a multidisciplinary level, from salting productions, building or infrastructure construction and rehabilitation, sanitary and drainage system, and so on. And in conclusion, it's about the development of this technology have enhanced the quality of human life in multi-aspect. So we value how the technologies can improving our life, particularly for coastal management. And then from room 2, we see that all management from acceptable biological catch of mud spiny lobsters, the need of mangrove conservation for sustainable aquaculture ecosystem, waste management to seaweed post-production and coastal community post-production training, require the setup for common motivations from the communities that serve as main contributing factor for achieving mutual interest and benefits, while also supported by environmentally friendly regulation and policy by the related government agency. And we also discuss in room 3 about the technology and management for maritime needs must be sustainable and be developed over the time, considering the urgent needs to protect marine wildlife and for sustainable resource usage through biofuel, and also improving the efficacy of search and rescue post-disasters. In room 4, there are 2 rooms for the room 4, yeah, but both of them are discussing about the effort coming from the management and process to maintain quality of wastewater, and coastal area. I think there are many solutions coming into discussions, making the further development are required to elaborate more discussion, more research in the coming future. And then from room 5, yeah, we discuss about the disaster risk management that needs to be carried out in various settings with various approach. Not all means can be replicated with the same success rate. Overall, the disaster risk management should be aimed not only to tackle a specific disaster with their own conditions, but also how we can understand, improve our insight on the preparation, capacity development, also city planning and development to establish a resilient city. And in the last sessions, we have Dr. Andrea, even though he is not in person joining in this conference, but we can see a very insightful presentations regarding small fishing boat stability applications that will be dedicated, yeah, to fishing communities. Before ending my remark, I would like to remind all presenters, yeah, to complete your corresponding full paper article. There will be communications between all the presenters with the IOP. So this is not through the community, but we still keep our WhatsApp groups, yeah, to exchange the informations. So hopefully, yeah, by the end of December, yeah, you can finalize the full draft, because we signed a contract with the IOP that all the papers should be final by the end of February 2023. Hopefully, by having this schedule, we can have a really nice proceeding, yeah, in the beginning of next year. So in the end of the year, we can still focus on involving and joining with the 4th of SRCM. I hope you can gain new insight, yeah, from this year's SRCMs. As SRCM is an annual joint international conference stations, yeah, for the next annual SRCMs around the end of the next years. Usually it is on November, so please keep in touch, yeah. And once more, thank you very much. Enjoy the rest of the day, and we will meet you next year. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Very well. Thank you, Mr. Aji Pamungkas, for the closing remark. It has been a remarkable journey from start to finish. We have discussed about sustainable and resilient coastal management throughout Indonesia as well as throughout the world. And that, ladies and gentlemen, means we have reached the end of today's joint online conference. We surely hope that you have obtained helpful insights and may come out of this conference possessing better understanding on sustainable and resilient coastal management means and measures. Before we would like to end this conference, we would like to provide you with a feedback link. If you have any critics or suggestions to the overall conduct of SRCM, you may give your feedback through the link that is currently being share screened right now, or you can access it by copying the link that later will be provided in the chat, which is s.id/SRCM 2022 feedback. In order for participants to be able to input this link, we would like to provide you with 1 minute in order to fill out the link. Thank you very much. I presume that the time required to input the link has been enough. So, in the end, thank you for attending and actively taking part in the 3rd Sustainability and Resilience Coastal Management Joint International Conference of 2022. I, alongside Kevin O'Brien, are your masters of ceremony for this conference. We are very happy to have guided this particular joint online conference. Once more, see you in the upcoming